Assalamualaikum warahmatullahi wabarakatuh. Our from class BMKA 1/1 Group B. So our title is Conventional Steering System. So this is our class name. So we go to the introduction.
Hello, my name is Nor Aiman WAFIQ bin IZHAM. My matrix number is B09-211-0234. So I'm going to present about introduction of a conventional steering system. A conventional steering system is a fundamental component in the automotive industry, responsible for directing the movement of a vehicle. Typically, it involves a mechanical linkage between the steering wheel and the vehicle's wheel, allowing the driver to control the direction of travel. This system employs a steering column, gear mechanism, a tie rods to transmit the driver's input to the wheels, resulting in change in the vehicle orientation. Conventional steering systems have been a standard in automotive world, offering a simple and reliable means of maneuvering vehicles for decades. As technology evolves, newer systems such as power-assisted and electric steering are emerging, but conventional steering remains a fundamental aspect of automotive design. Next.
Assalamualaikum. My name is SYAHIN binti ROSPI, matrix number B0921100003. So I would like to introduce the literature review on summary of our overall journal. So there are 5 titles of our journal. First is the conventional power steering system of vehicle and continuous improvement. It was published on December 2022. Second, modeling and experimental design approach for integration of conventional power steering, published on the year 2014. Third is the effects of independent wheel steering system on vehicle cornering performance and road safety of the smart cities, from article N-Shames Engineering Journal and published in the year 2022. The fourth is Future Trends for Automotive Steering System, was published on the year 2016. And the last one is an investigation on the energy saving effect of a hybrid electric power steering system for commercial vehicles. So the methodology and the result, our team will discuss on the discussion part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAFIZUDDIN. So I will talk about Journal 1, Conventional Power Steering System of Vehicle and Continuous Improvement. So in this journal, it will share about a mechanical steering system, hydraulic power steering system, which is HPS. It will share EHPS2, energy hydraulic power system. After that, there is a MATLAB simulation for the power consumption. We can see the result for the MATLAB simulating. So the comparison, if we compare the 5 different technique, we find that closed center valve system perform better than open valve system, but the complexity is high. So efficiency control of motor can reduce energy consumption and improve steering situation. But in motor driven pump, the motor is limited. Okay, that's all for me. Next.
Okay, next I will explain about Journal 2, which is Modeling and Experimental Design Approach for Integration of Conventional Power Steering. Firstly, the methodology, which has introduction, mathematical models, active steering control procedure, which is we have system state space model, and then the implementation of PID control, and then the linear and quadratic regulator, which is LQR, optimal algorithm control. Other than that, we have experimental work. The diagram shows the test rig setup, and after that, result and the discussion, which is the theoretical model result from the simulation compact SBW system version, shows the response and more. And lastly, the experimental result. This section summarizes lab tests of the SBW system, confirming effective performance and practically in mimicking a regular HPI system. Simulation shows responsiveness to an 80-second steering movement. Okay, next.
Sorry. Okay, so for the journal number 3 is the effects of independent wheel steering system on vehicle cornering performance and road safety of the smart cities. So these are the methodology, results, and also the vehicle model of our journal title. So the methodology, the development of a flexible steering system became necessary in order to better control the vehicle's cornering performance, since self-driving vehicles results in improvements in the field of active safety systems. Next, the AHMAD theory is conducted to obtain the inner and outer steering angles for a given target turning radius, thus using this angle as an input for the vehicle at degree of freedom, nonlinear model at certain vehicle speed and simulation time. So the figure below shows the definition of parameters of 8 degree of freedom vehicle model, and the result you can see there are 4 phases. First one is global X and Y vehicle coordinates to show the vehicle turning response. Second is the vehicle side slip and yaw rate to evaluate the vehicle yaw rate and side slip response. Third is the slip angles for each wheel used to measure the slip angle for each wheel. And lastly is the lateral vehicle speed and acceleration. So the vehicle model, most simplified, is a 2 degree of freedom vehicle model. And last one, the model validation, the 8 degree of freedom nonlinear vehicle model represent previously to capture the vehicle handling response during cornering before and after using the independent steering system. That's all from me. Next.
For the Journal 4, I will present about future trends for automotive steering system. The methodology for this journal is my introduction. I studied about the history of steering system, how they improve, and advancements, how they fix back in the past. So it will be the improvement in the performance and the current trends. So in this article, I can divide by 2 power steering system. First, electric power steering system. The advantages of electric power system is it is improved fuel efficiency, so we can save a lot of money. And then the challenges for this electric power steering, integration with autonomous system, and the future developments for this is enhanced feedback from the driver. After that, we can see the second system is steer-by-wire. The advantages of steer-by-wire is redundancy for safety, and the challenges is cybersecurity concerns. So these 2 systems have a lot of common. So I can say the relation between these 2 systems is both systems represents innovative approaches to steering technology with the potential to revolutionize the future of an automotive steering system. Thank you.
Okay, Assalamualaikum. My name is FIKRI. My matric number is B0921101002. 0201. I will talk about Journal 5, an investigation on energy saving and effect of a hybrid electric power steering system for commercial vehicle. Development of driving cycle need three steps. The first is data acquisition, and the second is identification of driving phase. There are three phases: urban, rural, and highway. And the third step is approximation of the steering number and the amount of each driving. The method that used for this in this journal is called rain flow counting method, which start at each peak and true, stop if the opposite true is negative, and convert time history data into steering cycle information for each driving phase. The reduced steering cycle number corresponded to reduce. Okay, and based on the result, as you can see in the slide, it can be concluded that the dynamic model has sufficient accuracy to verify whether hybrid EPF system can improve the energy efficient in simulation method. That's all from Journal 5. Next. Okay, in conclusion, when implementing the conventional AHMAD steering system, the deviation of the turning response is identified and minimized through the use of particle swarm optimization. Conventional steering systems have stood the test of time and are remain to be dependable and affordable option for a large number of vehicles, while they are benefit to use modern technologies such enhanced fuel efficiency and better driver assistance feature. Conventional systems are still useful for those who prioritize simplicity, durability, and more direct connection between the driver and the road. That's all from me. Thank you.
So this is our reference of our journal. That's all from me. Thank you.